Hello everyone and welcome back. Today, we are going to explore a simple question that leads to a surprisingly big story about our planet. Why does not Earth receive sunlight evenly? At first glance, it might seem like the sun shines on the whole world in the same way. After all, we all share the same sky. But in reality, the way sunlight reaches different parts of Earth is far from equal, and this single fact shapes climates, landscapes, and even life itself. To understand this, we need to picture Earth not as a flat surface, but as a round, spinning sphere floating in space. Because of this shape, sunlight hits the planet at different angles. Near the middle of the globe, around the equator, sunlight arrives more directly. The energy from the sun is concentrated into a smaller area, allowing the ground and air to warm up more efficiently. This is why these regions tend to stay warm throughout the year. As we move farther away from the equator, toward the north or south, the situation changes. Sunlight reaches these regions at a slanted angle. Instead of being focused, the same amount of energy is spread across a wider area. This reduces its warming effect and leads to cooler conditions. The difference may seem subtle, but over long periods of time, it has a powerful influence on weather patterns and temperatures. This uneven distribution of sunlight is the starting point for many of Earth's natural systems. It helps explain why some places are consistently warm, while others experience long winters or cooler seasons. By understanding this basic idea, we begin to see how a simple detail, how sunlight touches a round planet, sets the stage for the incredible diversity of environments we see across the world today. Stay with us as we continue exploring how this foundational concept connects to everything from winds and oceans to the climates we experience every day. Now that we understand Earth does not receive sunlight evenly, the next key idea helps explain why this imbalance changes throughout the year. Earth is tilted on its axis. Earth does not spin straight up and down. Instead, it is tilted at an angle of about 23.5 degrees as it travels around the sun. This tilt may seem small, but it has a huge impact on how sunlight reaches different parts of the planet. Because of this tilt, the angle at which sunlight strikes Earth constantly shifts as the planet moves along its orbit. When one half of Earth is tilted toward the sun, that region receives more direct sunlight for longer periods each day. The sun appears higher in the sky, and its energy is more concentrated. This leads to warmer temperatures and longer days. At the same time, the opposite half of the planet is tilted away from the sun, receiving less direct light and shorter days, which results in cooler conditions. As Earth continues its journey around the sun, this pattern slowly reverses. Areas that were once receiving strong sunlight begin to receive it at a lower angle, while regions that were cooler start to warm up. This steady shift is what creates seasons. It explains why temperatures rise and fall during the year and why different regions experience seasonal changes at different times. Importantly, the sun itself does not move closer or farther away in a way that causes seasons. The changes come from Earth's tilt and the way it alters sunlight angles. The same sunlight can feel intense and warming when it hits directly, or gentle and weak when it arrives at a slant. This axial tilt works together with Earth's spherical shape to shape global climate patterns. It influences how heat is distributed across the planet and helps explain why some regions experience dramatic seasonal contrasts while others remain relatively stable year-round. Understanding Earth's tilt gives us a deeper appreciation of how motion, angle, and time combine to create the rhythms of the natural world we experience every day. After understanding Earth's shape and its axial tilt, we can now focus on another crucial factor, latitude. Latitude refers to how far a place is from the equator, and it plays a major role in determining a region's climate. The equator sits at the center of the planet, receiving sunlight that is more direct and consistent throughout the year. Because the sun's rays hit this region at a steep angle, the energy is concentrated and efficient at warming the surface. As a result, areas near the equator tend to remain warm year-round, with relatively small changes in temperature between seasons. As we move north or south away from the equator, latitude increases, and the angle of incoming sunlight becomes lower. The sun appears closer to the horizon, especially during certain times of the year. This causes the same amount of sunlight to be spread over a larger area, reducing its heating power. These regions experience cooler temperatures overall and more noticeable seasonal changes. This is why Earth can be divided into broad climate zones based on latitude. Near the equator, we find tropical regions that are generally warm and often humid. In the middle latitudes, known as temperate zones, temperatures vary more clearly across the seasons, with warm summers and cooler winters. Farther toward the poles, polar regions receive very little direct sunlight, especially during winter months, leading to cold conditions for much of the year. Latitude also affects the length of daylight. Near the equator, day and night are fairly equal throughout the year. Closer to the poles, daylight hours can change dramatically, with very long days in summer and very short days in winter. These shifts further influence temperature and weather patterns. By understanding latitude, we begin to see how Earth organizes its climates on a global scale. It explains why certain plants, animals, and ways of life are suited to specific regions. Latitude acts as a natural guide, shaping how energy from the sun is distributed and helping define the diverse environments found across our planet. Even though sunlight provides Earth's energy, it does not stay where it lands. The next key idea is that the atmosphere constantly moves heat and moisture around the planet, shaping climates far beyond where sunlight first arrives. When air near Earth's surface is heated by the sun, it becomes lighter and rises. Cooler air, being heavier, sinks. This simple process creates large-scale circulation patterns in the atmosphere. As warm air rises near the equator, it begins a long journey toward cooler regions, while cooler air flows back to replace it. These movements form global wind systems that act like Earth's natural heat distribution network. As air rises, it cools and releases moisture in the form of clouds and rainfall. This is why many regions near the equator experience frequent rain. As the air continues moving away from these areas, it becomes drier and eventually sinks back toward the surface. When air sinks, it warms and dries out, creating conditions where rainfall is less likely. Over long periods of time, this process leads to the formation of dry regions and deserts. These wind patterns do not operate randomly. They follow fairly consistent paths influenced by Earth's rotation and shape. This creates belts of prevailing winds that guide weather systems, influence ocean waves, and affect how storms travel across continents. Atmospheric circulation also helps explain why regions with similar sunlight levels can have very different climates. Some places receive steady moisture carried by winds, while others are shielded from it. The movement of air determines where clouds form, where rain falls, and where dry conditions persist. By redistributing heat and moisture, the atmosphere connects distant parts of the planet. What happens in one region can influence weather far away. This constant movement is a key reason Earth's climate system is dynamic and interconnected, rather than static or uniform. Understanding atmospheric circulation helps us see climate as a global system, one driven not only by sunlight, but by the endless motion of air shaping the world we live in. Beyond the atmosphere, Earth has another powerful system that shapes climate across the globe, the oceans. Covering more than 70% of the planet's surface, oceans store vast amounts of heat and release it slowly over time. This makes them one of the most important regulators of Earth's temperature. Water heats up and cools down much more slowly than land. Because of this, oceans act like a giant thermal buffer. During warmer periods, they absorb excess heat from the sun. During cooler times, they release that stored warmth back into the air. This process helps reduce extreme temperature changes, especially in coastal regions, making climates more stable and moderate compared to inland areas. Ocean currents play an even more direct role in shaping regional climates. These currents are massive rivers of moving water that flow through the oceans, carrying warm or cold water across great distances. Warm currents transport heat from tropical regions toward higher latitudes, while cold currents bring cooler water toward lower latitudes. When warm ocean currents flow near land, they raise air temperatures and often increase moisture in the atmosphere. This can lead to milder winters and higher rainfall. In contrast, cold currents cool the air above them and tend to reduce moisture, often creating drier conditions along nearby coastlines. Because of ocean currents, regions located at similar latitudes can experience very different climates. Some coastal areas remain relatively warm and wet, while others become cooler or more arid, even though they receive similar amounts of sunlight. This explains why climate cannot be understood by sunlight alone. Oceans also interact closely with the atmosphere. Winds help drive ocean currents, while ocean temperatures influence wind patterns and weather systems. Together, they form a connected system that constantly exchanges heat and energy. By moving warmth around the planet and moderating temperature extremes, oceans help create the wide range of climates we see today. They remind us that Earth's climate is not controlled by a single factor, but by the continuous interaction of land, water, air, and sunlight working together over time. In addition to sunlight, air, and oceans, Earth's physical landscape plays a major role in shaping climate. Mountains, elevation, and terrain can dramatically change weather conditions over surprisingly short distances. One of the most important effects of terrain is altitude. As elevation increases, air pressure decreases, and temperatures drop. On average, the air becomes cooler the higher you go above sea level. This is why mountain peaks can be cold and snowy, even in regions that are warm at lower elevations. Entire climate zones can shift simply due to height, creating cooler conditions in highland areas surrounded by warmer lowlands. Mountains also influence how air moves. When moist air is pushed toward a mountain range, it is forced upward. As the air rises, it cools and moisture condenses into clouds and rainfall. This often leads to lush vegetation and wetter climates on the side of the mountain facing the incoming winds. Once the air passes over the mountain peak, it begins to descend on the other side. As it sinks, it warms and dries out, reducing the chance of rainfall. This creates a drier region, known as a rain shadow. Over long periods, rain shadow effects can lead to the formation of deserts or semi-dry landscapes, even relatively close to wetter regions. Terrain also affects how sunlight is absorbed and released. Valleys, plains, and slopes can heat and cool at different rates, influencing local wind patterns and temperature variations. These small-scale differences help explain why nearby locations can experience noticeably different weather. By shaping airflow, controlling rainfall, and altering temperature with elevation, mountains and terrain add another layer of complexity to Earth's climate system. They show that climate is not only a global process, but also a local one, influenced by the shape and structure of the land itself. Together with atmospheric and oceanic forces, Earth's terrain helps create the rich variety of environments found across the planet, from snowy peaks to dry plains and fertile valleys. The final key idea is that the surface of Earth itself helps shape climate, and in many cases, climate and the environment influence each other in an ongoing cycle. What covers the ground, such as forests, deserts, ice, or water, affects how much heat is absorbed, stored, or reflected back into space. Different surfaces interact with sunlight in different ways. Dark surfaces, like forests or oceans, absorb more solar energy and warm up more easily. Lighter surfaces, such as ice, snow, or sandy deserts, reflect a larger portion of sunlight away. This reflection reduces warming and can keep regions cooler over long periods. Because of this, areas covered in ice or snow tend to remain cold, reinforcing the conditions that allow ice to persist. Vegetation plays an especially important role. Plants release moisture into the air through a natural process that helps regulate temperature and humidity. Forested areas often stay cooler and more stable because moisture in the air absorbs heat and encourages cloud formation. In contrast, regions with little vegetation tend to heat up more quickly during the day and cool down faster at night, leading to more extreme temperature swings. As climates change, surface conditions can change as well. A warming climate may reduce snow cover or dry out forests, exposing darker ground that absorbs more heat. This can further increase temperatures, creating a feedback loop that strengthens the original change. Over long timescales, these feedbacks can reshape entire regions. Human-built environments also influence local climate. Cities, with their dense structures and paved surfaces, often retain heat more than surrounding rural areas. This can create warmer conditions in urban regions compared to nearby landscapes. By affecting how energy is absorbed and released, Earth's surface and vegetation help fine-tune climate patterns. They show that climate is not just driven by the sun and atmosphere, but also by the living and non-living features covering the planet. Together, these elements form a dynamic system that evolves continuously over time. After exploring sunlight, Earth's tilt, latitude, atmosphere, oceans, terrain, and surface features, we arrive at a crucial realization. No single factor creates climate on its own. Climate is the outcome of many interconnected systems working together over long periods of time. Sunlight provides the initial energy, but how that energy is used depends on where it arrives, the angle at which it strikes the surface, and how long it stays. The atmosphere then redistributes this energy through winds and circulation patterns, moving heat and moisture across vast distances. At the same time, oceans store and transport heat, smoothing out temperature extremes and shaping regional weather conditions. Geography adds another layer of complexity. Mountains redirect airflow, influence rainfall, and create sharp climate contrasts between neighboring regions. Elevation alters temperature, while valleys, plains, and coastlines change how air and water interact. Even the surface of the land, whether covered in forest, ice, sand, or water, affects how much energy is absorbed or reflected. What makes Earth's climate especially dynamic is that these systems constantly influence one another. A shift in ocean temperatures can alter wind patterns. Changes in vegetation can affect rainfall and surface temperatures. Over time, small adjustments in one part of the system can lead to noticeable changes elsewhere. This interconnectedness explains why Earth has such a wide range of climates, from humid rainforests to dry deserts and icy polar regions. It also explains why climates are not fixed. They respond to long-term shifts in natural systems, and in more recent times, to changes in how humans interact with the environment. Understanding climate as a system helps us move beyond simple explanations. It shows that Earth behaves less like a machine with one control switch, and more like a living network, where balance, movement, and interaction shape the conditions we experience every day. By seeing climate as the combined result of many forces working together, we gain a clearer picture of why our planet is so diverse and why even small changes can have far-reaching effects across the world. As we move forward, it becomes clear that climate does more than describe weather patterns. Over long periods of time, different climates shape the natural world and influence how life develops in each region. Plants and animals adapt to the conditions around them. In warm and wet climates, dense forests and rich ecosystems can thrive. In dry regions, vegetation develops ways to conserve water, while animals adapt to survive with limited resources. In colder climates, life evolves strategies to endure low temperatures and seasonal changes. These adaptations are not sudden. They emerge slowly as living things respond to their environment generation after generation. Human societies are shaped in similar ways. Climate influences what crops can grow, how people build shelter, and how communities organize daily life. In regions with reliable rainfall, agriculture can flourish, supporting larger populations. In colder or drier environments, people often develop different strategies, such as seasonal movement, food storage, or specialized tools. Over time, these responses become part of culture, tradition, and ways of living. Climate also affects how landscapes look and function. Rivers, deserts, grasslands, and forests all form in response to long-term climate conditions. These landscapes, in turn, influence weather patterns, water availability, and soil quality, creating a continuous interaction between climate and environment. Importantly, these differences do not reflect ability or value. They simply represent different paths of adaptation to different conditions. Human creativity, cooperation, and resilience appear in every climate zone, shaped by local challenges and opportunities. By understanding how climate shapes life and society, we begin to see Earth as a mosaic of interconnected environments. Each region tells a story of adaptation, balance, and change. Climate is not just a background feature of the planet, it is a powerful force that quietly guides the development of ecosystems and civilizations across time. This perspective helps us appreciate diversity, not as division, but as a natural outcome of living on a planet with many climates and many ways to thrive. To conclude this journey, the final idea is an important one. Earth's climate is not static. It is a dynamic system that has been changing throughout the planet's history and continues to evolve today. Over millions of years, Earth has experienced periods that were much warmer or much colder than the present. Ice ages advanced and retreated, sea levels rose and fell, and ecosystems shifted as climate conditions changed. These long-term changes were driven by natural factors such as variations in Earth's orbit, shifts in ocean circulation, volcanic activity, and changes in atmospheric composition. Together, they slowly reshaped global climates and environments. What makes Earth's climate system unique is its sensitivity. Small changes in one part of the system can lead to larger effects elsewhere. A slight shift in temperature can influence ice cover, which then affects how much sunlight is reflected or absorbed. Changes in ocean temperatures can alter wind patterns and rainfall far from their source. Because everything is connected, climate responds over time rather than remaining fixed. For most of human history, people adapted to the climates they inherited. However, as societies became more advanced and interconnected, human activity also began to influence natural systems. Changes to landscapes, vegetation, and energy use can affect how heat and moisture move through the environment. This adds a new layer to an already complex system. Understanding that climate is dynamic helps us see the planet more clearly. It reminds us that Earth has always been changing, but also that balance matters. Stability allows ecosystems and societies to thrive, while rapid shifts can create challenges for both nature and human life. By recognizing climate as a living, evolving system shaped by sunlight, air, water, land, and time, we gain a deeper respect for the planet we depend on. Earth's diverse climates are not random, they are the result of countless interactions unfolding over vast stretches of time, and they continue to shape the world we experience today. As we come to the end of today's journey, let us take a moment to look at the bigger picture. Earth's many climates are not accidents or mysteries without explanation. They are the result of how sunlight reaches a round, tilted planet, how air and oceans move heat around the globe, and how land, water, and living systems respond over time. Every desert, forest, mountain range, and icy plain exists because these forces are constantly working together in balance. What makes this story truly remarkable is that climate connects everything. It links the sky to the ground, the oceans to the land, and the past to the present. The differences we see across the world are not signs of separation, but reflections of adaptation and diversity. Each region tells its own story, shaped by the same natural laws, but expressed in unique ways. By understanding how climate works, we gain a deeper appreciation for the planet we live on and the delicate systems that support life. This knowledge reminds us that Earth is dynamic, interconnected, and always evolving, and that we are part of that system too. Thank you for spending this time with us and exploring the story of our planet. If you enjoyed today's discussion, we are glad you were here. Take care, stay curious, and we will see you again in the next journey.